5.1, using fundamental identities. What you should learn: how to recognize and write fundamental trig identities, use trig identities to evaluate trig functions, simplify trig expressions, and rewrite trig expressions. We introed identities last chapter, but now we're going to really delve into them. And what we use them for is a lot of things in trig. We evaluate trig functions with them, so we could like simplify a trig identity down. We could simplify some trig expressions. We could develop additional trig identities. And we could solve trig identity. We could solve equations using trig identities to like rewrite and reshape a problem. So that's why they're really important. And a lot of this stuff we just gotta memorize. So like reciprocal identities, hopefully these are all memorized already, right? Sine goes with cosecant, cosecant goes with sine, cosine goes with secant, tan goes with cotan, like all the reciprocal ones. These ones are super important, right? Tan is sine over cosine. I think it's another one we hopefully should have memorized by now. Tan is sine over cosine. And then cotan is the reciprocal of that. So I always just remember tan is sine over cosine. So when I think of cotan, I just think, oh, tan is sine over cosine, cotan is the reciprocal, cosine over sine. Then we get to the big ones. So sine squared plus cosine squared equals 1. That's a massive one. It's Pythagorean identity. It's just a squared plus b squared equals c squared in a unit circle. So sine squared plus cosine squared equals 1. But equally important is if you rearrange this, you get like sine by itself. So you subtract cosine from both sides. You get sine squared equals 1 minus cosine squared. So they're all u. And the same thing, if you get cosine itself, you get cosine squared equals 1 minus sine squared. And these are also very important to have memorized. They're like big. We use these a lot. We probably use this more than sine squared plus cosine squared equals 1. We use the fact that sine squared is 1 minus cosine squared and cosine squared is 1 minus sine squared. The other two, 1 plus tan equals secant squared, 1 plus cotan equals cosecant squared. I memorize these also. The way I do it is I just tell myself it's always 1 plus tan. So I keep that in mind. Or 1 plus tan squared. So I know it's going to be 1 plus cotan squared. It's going to be 1 plus tan squared. Like I know the tans get the 1. And the cos go together. So that's how I keep it straight in my head. I memorize that it's always tan plus 1. It's not secant and cosecant plus 1. It's the tans plus 1. And the cos go together. So cosecant goes with cotan, which means secant goes with tan. So that's how I memorize that one myself. These are the cofunction identities. So if you just take pi over 2 minus u, or minus an angle, you get their cofunctions. These are just like, what do they go with? Who's their buddy? So sine goes with cosine, tan goes with cotan, secant goes with cosecant. If you just kind of memorize like who's buddy, then you're fine. Like sine goes with cosine, tan goes with cotan, and secant. Like I think for this one's pretty straightforward which one goes with which one. It's the way you would probably line them up anyway. And then the even odd identities. We talked about this a little bit last chapter also. The key thing here, right, is only cosine is even. That's the only one. And then secant, because it's cosine. And all that means is if you have a negative inside the cosine, you could pull it goes away, like it doesn't do anything. So cosine x. While the rest of them, they pull it out. Like sine, see a negative side, you can pull it out, it's just negative sign. But cosine gets rid of the negative on the inside of it. So like practical terms, if you have like, what's cosine of negative pi? It's the same thing as saying what's cosine of pi. That's what's going on there. So those are even odd identities. Okay, let's use some of the identities to actually do some problems. So this first one here. Use the value of secant u equals negative 3 over 2 and tan u is greater than 0 to find all 6 trig functions. So they want you to use the trig identities. I honestly don't use trig identities for this one like this. I'll just make a triangle. So first we gotta figure out where we're at. So all students take calculus. Remember secant's just cosine. So cosine is positive at a and c and negative at t and s. Tan is positive. So remember tan would be positive at a and at t. So where's cosine negative and tan positive? Right here. So this is going to be a quadrant 3 triangle. Like that. We have secant, right? It's opposite of cosine. So GATOA, AH. So secant would be the opposite, H over A. So that means my hypotenuse is 3 and my adjacent is 2. And the 2 would get the negative because hypotenuse is always positive. Also, you're going to the left. So all we got to do now is find the missing side. And then we're done with this problem. We can do all 6 trig functions. So we're going to do a squared plus b squared equals c squared. We'll say negative 2 plus b squared equals 3 squared. 4 plus b squared equals 9. B squared equals 5. B equals plus and minus try 5. In this case, negative rad 5 because we are going down. Now if you want all 6 trig functions, well, you have them, right? We have sine SOHCAHTOA is a negative rad 5 over 3. Cosine. Honestly, I don't even need to look at the graph. I could just flip secant. So negative 2/3. But either way works. Tan is opposite or adjacent, so negative rad 5 over negative 2, which is just rad 5 over 2. Then just reciprocal functions. Cotan, just flip it. 2 over square root of 5. You could rationalize if you want. And then we cosecant, because we already have secant. It's just 3 over negative 5. Same idea. If you want to rationalize, go ahead. I'm fine with it. Not. Next one. In the exercise, use the given values to evaluate if possible all 6 trig functions. So same idea. What's changing here? Well, nothing really. It's the same concept. You just got to figure out what quadrant you're in and make a triangle. So all students take calculus. Tan is positive, so that's going to be A and T. Secant, which is just cosine again, is negative, right? Cosine is positive here and here, so it's negative here. We're in quadrant 3 again. So that's where you draw your triangle in quadrant 3. Now, just use the fact that it's a fraction, right? TOA. Opposite is 7, adjacent is 24. And then you can use this to verify. This is secant, which is opposite of cosine, right? So cosine is ka, so this would be h over a. So hypotenuse is 25, and adjacent is negative 24. The only thing I'm missing is that 7 should be negative also, right? We went to the left and we went down. It was a negative here because the negatives cancel each other out and they're both positive. But it was negative, but 24 was negative there. So that's your triangle, and then we could do all 6 trig functions. I'll skip that part because I just did it, but you can do all 6 trig functions again. Let's get to actual like using our identities. So here's our first one. We want to simplify this identity if possible. This is a binomial, right? There's 2 terms here. And the first thing I noticed is that they both have sine. So my inclination is to factor out the sine. So we're going to get sine on the outside. That leaves us with cosine squared x minus 1 on the inside. From here, we're not totally simplifying it. We should go a little further. There's actually a couple ways we could do this. I'm going to take the more direct approach, which is let's change this cosine. Like the only thing I could change here is cosine squared. What does cosine squared equal? If you remember our things up here, cosine squared is the same thing as 1 minus sine squared. So I'm going to change this to 1 minus sine squared. So I'm going to show a lot of work just I want you to see where I'm coming from. So I'm just going to rewrite it. And now we have a positive one and a minus one. So these cancel out. And we have sine x times negative sine squared x. Multiply those together, you get negative sine cubed x. By the way, that's the same thing as saying this, negative sine x cubed. That's just the way we write it in trig because it's a lot easier to write this than to write this all the time. So we write this instead. So, but if you see that, that's the same thing as saying the whole thing of sine cubed or squared. Same thing with the squared. So that's one way to go. Another way you could have gone is this way if I just start there. And we add this. Another way you could have done this is you could have factored out a negative from here. So if you remember when you factor out a negative, it switches everything on the inside. So it'll be 1 minus cosine squared. And then that is just sine squared. So negative sine of x times sine squared. And you get the same thing. So lots of ways you can do it. When you do simplification, when you do trig identities, there's usually lots of ways to get the same answer. Okay, next we have to factor this. So the general idea here is if you're having a hard time factoring stuff, you can always do this. You just say secant equals like w. So I get, this is saying w minus 1. And that's easy to factor. That's just w minus 1, w plus 1. Then you can always put the secant back. It's called like a lot of people call it u substitution. I like to use w just because it's easier for me to write w and cw. But something like that. That's one way to do it. Now, when you get better at it, you don't need to do that. You can just go, oh, that's going to be secant minus 1, secant plus 1. But same thing here. Like if you have a hard time factoring this, you could just make tan into like something like w. And you get 4w squared plus w minus 3. And for a lot of people, that's a lot easier to factor, right? You multiply the first and last, 1 down the middle, 4w, doing big X. The two things that multiply to get negative 12, but add to get 1 is 4 and negative 3. You reduce this, w plus 1, so I get w plus 1, 4w minus 3. Right? I did all that, factored it, and I'm going to put instead of w, I'm going to put back my tan. So tan of theta plus 1 for tan of theta minus 3. Again, you don't have to do that. If you're good, you can just like factor it normally. But if you're having a hard time, it's easier just to make one of the variables w and then factor it from there. This one, I want to be able to factor it, but they don't match. So we're going to use our identities. Now, the thing is, cotan, I can change the cosine over sine, but that's not really going to help me. Cosecant, if you remember, one of the rules is the cos go together. Cosecant turns into cotan. Cosecant squared turns into cotan. So I'm going to use that one. So we're going to change cosecant to what it equals, which is the cos go together, and it's 1 plus a tan. So this is 1 plus cotan squared x. Everything will stay the same, minus cotan x minus 3. Let's simplify a little bit, and you get cotan squared x minus cotan x minus 2. And then we're going to have to factor this. Again, if you're having a hard time factoring it, just make cotan equal to w. So I'm going to get w squared minus w minus 2. That's going to be w minus 2, sorry, almost messed that up. And w plus 1 is a combination. If I fill out correctly. And then put your cotan back. So this is cotan x minus 2, cotan x plus 1. And it's factored. Simplify this one. Sine plus cotan plus cosine. So my general rule is this is just straight simplification one. If you're not sure, I would change. You always want to keep sine and cosine. Don't change those. If it's sine squared, cosine squared, it's a little different. But I generally try to keep my sine and cosines. And then change others to sine and cosine. It's my general rule. So like here, cotan, I'm going to change that. Cotan is the same thing as, right? So cotan is the reciprocal of tan, and tan is sine over cosine. So cotan is cosine over sine. And then there's still the cosine here. Okay, so that didn't really help me much. I could simplify this side. We're doing this live. So I could get cosine t squared over sine. That's good. So what do I do now? Like I still have two things. Well, generally one rule you want to do is combine these two things. So we're going to put this guy over 1, and I want a common denominator, right? So this is over sine. I need this to be over sine. So we'll multiply both top and bottom by sine so that they match. I'll show you this, the middle step. I get sine squared t plus cosine squared t. I still have to show the middle step. Over sine. Now most of the time you can skip this and just go straight to here. You're going to go to sine squared t plus cosine squared t over sine of t. Right? Because once you get the common denominator, you can just combine them. So you're going to add this plus that to get this. I'll show you the middle step right here. Right? Sine squared over sine plus cosine squared over sine. They're combined. I have sine squared plus cosine squared. We should know what that is. That is 1. So now I have 1 over sine of t. And that's, you're still not done. You want to write that? That is the same thing as cosecant. So that's equal to cosecant t. And that's it being simplified. That's simplifying using your trig identities. It's something like that. Right? So you notice I had two separate things. I wanted to combine them. So you want to use the common denominator and then use your identities to help you down. Okay, so same thing with this one. Rewrite 1 over 1 plus sine x so that it's not in fraction form. So we want this to make this not a fraction. So we're going to use a trick. And the trick is we want to use the fact that a minus b, I need a little more space, a minus b times a plus b equals a squared minus b squared. So I know the same time I see something that's like 1 plus sine or 1 plus cosine, 1 minus sine, 1 minus cosine, that we're probably use the difference of two squares here. So I want to rewrite this. I'm going to multiply both top and bottom by 1. I'm going to do 1 minus sine x. That way, when I multiply them, I'm going to get a difference of two squares. And I could do that because you're multiplying by 1, right? It's the same thing over each other. So that's a trick we're going to use a lot. So on top, I'm going to have 1 minus sine x. On the bottom, you can multiply them, right? 1 minus sine, 1 plus sine, but it's just a difference in two squares. It's going to be 1 minus sine squared. That. And right now you're like, ooh, you just made it uglier. Well, we're going to do some things. 1 minus sine squared is cosine squared. So I have this 1 minus sine x over cosine squared x. And you might be going like, that doesn't do anything. Well, what you can do now is you could separate this. I don't want this to be a fraction. I'm going to separate this. So we're going to break 1 over cosine squared x minus sine over cosine squared x. So I'm going to separate it like that. Again, because they want not a fraction form. So we're just trying to do things to make it not a fraction. So I multiply by this. I did that. I separated. That's a rule you could do. Keep them the same denominator. Separate them out. This side, reciprocal cosine is secant. So this side is done. That's a secant squared x. This side, I can't just like do anything because one's squared and one's not squared. So it's like not tan because bottom squared. What I could do is another trick. I could separate it. I'm going to write it like this. Sine of x over cosine of x times 1 over cosine of x. Right, I'm going to separate. I'll take and pull one of the cosines and put it to the side like that. And then now we're almost done. Because this is tan. This is secant. And we still have a secant squared over here. And now we're done. Honestly, we could even factor some more. I could factor out a secant from both of them. But I think that's as far as I wanted. I guess they might want secant x secant minus 10, just in case. But that's rewriting this in so it's not a fraction. And that's how we use trig identities.